let's have a look first of all at all the materials that we're going to need today. We do need a couple of jars. I have 2 here, but I'd recommend if you have more than 2, maybe get 3, 4, 5 together. Or of course you can always clean in between, that's totally up to you. We need baking soda. Make sure it's not baking powder, because baking powder doesn't work for what we're going to do. It does have to be baking soda. Some vinegar. You don't need a full bottle. A few drops are fine, so don't worry. We need gloves, or at least 1 glove per person. And we need red cabbage indicator. Ideally, it would be great if you also had some kind of tray or some protection or newspapers to spread over the kitchen counter, because it might get a little bit messy. So for the red cabbage indicator, it's best to make it the day before, because what you need to do is you need to boil up some red cabbage and you need to wait afterwards for the red cabbage indicator to cool down again before you use it in the workshop. So I'm just going to show you what I did the day before. Basically, I just ripped up a few bits and pieces of red cabbage, put them into a bowl and poured some boiling water over it. Make sure you don't use any glass bowl, because that might burst with the hot water. So make sure you use some kind of bowl that's actually suitable for that. What you can also do, and that's even easier to be honest, what you can also do is just rip up the red cabbage, put it into a pot, pour some water from the sink over it, and just boil it up on the stove. So I'm just going to show you. The reason I'm doing it that way is just for demonstration, to show you how fast the water changes color. Again, I would prefer doing in the stove when you're at home, because there's no rush at all. Prepare the day before and you will see the color change as well. So the reason I'm using it like this is for demonstration. You can see I only just poured the boiling water over it, over my red cabbage pieces, and it's already changing color. We leave it there for a while and come back to it later. For the very first experiment that we're going to do today, we need a glove, some vinegar, baking soda. Again, make sure it's soda and not powder, a jar, and I would always use a tray just to avoid to get everything messy in the kitchen. You can also, if you want, get a spoon. It's not absolutely necessary, but it might make things easier. Right, so what we're going to do is, and that would be good if you have somebody to give you a hand or help you a little bit here. You're going to take the glove, open it up like this. We take our baking soda. There we go. And we just pour a little bit of baking soda into the fingers of our gloves. Maybe fill, like 1 finger now filled, 1.5 fingers filled. Say maybe fill up 2 fingers. That should be fine. Use a spoon if you don't have baking soda that's packaged like this. So up to you. It might be easier to use a spoon for this part and just spoon the baking soda into your glove. Once you've done that, just make sure you get the baking soda right into the fingers of the glove and briefly put it on the side. Now we're going to use the vinegar and our jar. And we just pour some vinegar into our jar. Feel free to dilute the vinegar 1 to 1, not more, or you just use it as it is. I suppose it also very much depends on how messy you can get in your kitchen. I think we all love a good bit of mess, but keep in mind you will have to clean up afterwards. So I'm going to pour some vinegar now into my jar, just there. And what I'm also going to do is I'm going to add a little bit of water because I'm using concentrated vinegar. There we go. So what I did now, half of the jar is, or half of what I have in here is vinegar, and the other half approximately is water. Right, to the exciting part. And again, here it would be good if you have somebody to help you, because what we do now is, again, we take the glove like this and we put it over the rim of our jar. So far so good. Okay, so I just cleaned a few things out of the way. Make sure you have some good space in the kitchen. Get your jar and your glove with the baking soda inside your glove and your vinegar and water, so your diluted vinegar in your cup or in your jar or in your glass. Get it ready, have it in a tray or some newspaper, and now slowly rise up the fingers of the glove that contain the baking soda. And then slowly pour it all into your jar. You can see something is happening there. Ooh, there we go. And it's going to be an explosion. Right. It's not a dangerous explosion, but I think it is a pretty cool thing. And I suppose you know now why I cleaned a few things away before I started with this, and while I'm using a tray. Right, there we go. So what happened? Can anyone have a guess? If your reaction was as explosive as mine was just now, you might want to wash your hands. It's not dangerous at all, it's only vinegar and baking soda, but the smell is quite strong and it does get a bit sticky on your hands. So maybe rinse them, give them a quick rinse, and then we're going to have a look at what was actually going on there. Because what we did is we had baking soda, which was a solid, you know, this kind of powdery solid. We had a liquid down there, the vinegar, diluted with water or pure vinegar, concentrated vinegar, excuse me. But what happened is something in this reaction caused that glove to stand up, to blow it up like a balloon. And I think if you watched closely, and I'm sure you did, you could see all those bubbles rising up from there and the foam that was coming in. I think you could probably hear the sizzling sound. That appeared as soon as we poured the baking soda into the vinegar. And those bubbles mean that some gas actually developed in there. And that happened when the baking soda reacted with the vinegar. So they reacted and they formed a certain gas. And that gas, I'm sure you've all heard of it, and I'm sure you probably have guessed by now while I'm just talking around it. So that gas that formed when you mix vinegar and baking soda is called carbon dioxide. It is all in the air around us, but it is very light, so that's why the gas kind of rises up, and this is why it filled the glove. It still fills the glove, as you can see here, and this is what happened in the reaction, and this is why we have our little hand here now, our gloved hand, standing up above our jar. So yeah, great job. If it didn't work the first time, or if your reaction was too strong, or if it was too weak, if you didn't get enough gas, carbon dioxide, to fill the glove, try it again. That's the fun, that's the good part of chemistry, the good part of kitchen science. You can just do it again and again until you get it absolutely right. For now, I'd just like to say good job, everyone. Give your hand a high five. Well done. And I think you can repeat this experiment in your own time. You can maybe observe a bit closer how those bubbles form down there, how long it takes, you know, what ratio between baking soda and vinegar gives the strongest reaction. Whatever you want, there's loads of things that you can explore around that. But I suppose you can do this in your own time, and we're just going to move on to our second experiment today. Okay, welcome back. I've kind of changed my setup here a little bit, and the star of the second part of today's workshop is going to be our red cabbage indicator. It looks quite dark here. It is dark purple. If yours is a bit lighter, no bother at all. It's no problem at all, as long as it is in some way purple. What I also have here, and you can lean back and listen and watch for a while, is 2 clear liquids. We don't know what it is. I can hear you all saying, oh, come on, that's just water, isn't it? We don't know. Because we've just seen that vinegar, actually, there, labeled vinegar, looks clear like water as well, but it's not. When we talk about vinegar, it's easy to tell it apart from water just because of the smell. I think we all know the acidic smell, not the greatest, but it is a way for us to tell things apart. And smell at these two. Don't smell much. What other ways would there be to tell 2 liquids apart that look exactly the same? Not just liquids, anything really, any kind of substances that look the same. You can smell them, you can taste them, or you can just try different reactions and see what happens when you pour one into the other, or when you bring them in touch with a third substance or a third liquid. And this is exactly what alchemists and chemists did for a very long time. They started by smelling, started by tasting, and touching different substances, which is not always a good idea, and I think that might be one of the reasons why the death rates of chemists and alchemists might have been a bit higher in the ancient times than it is now. But luckily, we have loads of different techniques and methods now to tell different substances apart, to identify exactly what kind of chemicals we have in the different materials. And we also know how to test those 2 clear liquids. And you can actually do that at home, because a lot of that is thanks to a very famous scientist, a very famous chemist and natural philosopher, who grew up not far from Waterford City. He was born in Waterford County in Lismore. You probably have seen Lismore Castle. It's hugely impressive. When you drive into Lismore, it's the first thing you see, and it's always one of my favorite sites. So Robert Boyle is his name. He grew up in Lismore. He was born in Lismore, grew up in Lismore. He was educated then all around Europe and finally settled in England, where he did loads of scientific experiments. And he was the first chemist at the time who actually used something called an indicator. An indicator is something that indicates, obviously, hence the name, if some substance is acidic or basic. An acid, we were saying that early on, is something like vinegar. You can always distinguish it by its smell. A base or a basic substance is the opposite of an acid, and it could be something like baking soda. Bleach, again, do not use bleach in any of those experiments, and don't touch bleach. It is quite harmful to your skin. Acids and bases, when they're strong, they're all harmful to your skin. But what we do here is we're working with vinegar, we're working with baking soda, so they're all fine, they're all safe to use. But what Robert Boyle did is he was the first one to use indicators, so he did not rely on his senses, like smelling and tasting different substances, to figure out what they are, but he developed a scientific method to distinguish and to determine and identify different substances. He was the first one who figured out that an indicator might help, and I think we could just use some kitchen chemistry and not exactly replicate what he did, but very close to it. So if I'm just going to hold this one up first, it's a clear liquid. I'm going to pour in some of the red cabbage indicator, and you just watch closely for now. Whoa! Did you see the color change? This here is blue, this here is purple. So what happened is our purple indicator changed into blue as soon as it touched the previously clear liquid that we had in there. Just going to put this aside. Now, what do you think is going to happen when I pour the purple indicator into the second clear liquid? Turn blue, explode, We'll see. It's fantastic, isn't it? It's turning all pinkish, reddish. So what we have now is our blue liquid, our red liquid, and our purple indicator. And that actually shows us, and I'm going to solve the mystery right now, that this one here is a base. So basically what I did, I mixed baking soda with water and dissolved it. And because it's a base, it turns blue when we mix it with the purple indicator. This one here is vinegar, and because it's an acid, it reacts with the purple indicator and it turns into this very bright pink or reddish color. As you can imagine, there's loads now that we can play around with at home, in the kitchen in particular, because we're using loads of acids and bases in the kitchen every day. Actually, you know what we could do? We could just repeat our experiment that we did before with the glove, the baking soda and the vinegar, because now we can prove what is happening inside the jar when we mix a base with an acid, so the baking soda and the vinegar. You just have a quick think about what you expect to happen, and I'm going to prepare the experiment and I'm back with you in just a second. Okay, so we're back and I have it already here. These are our two references. It is always good to have a reference just to compare and see does it turn out the same way. You can compare colors, and if whatever we are going to do is turning out red, we know it's an acid. If whatever we're going to do is turning out blue, we know it's a base. And what happens when we mix blue and red? We get purple, right? So if we mix a base and an acid, it is turning, whatever we mix there is going to be neutral, and the color, I suppose you guessed it by now, is going to be purple. So base, acid, neutral. What I have here is, I prepared the vinegar already, and just to prove that this is actually vinegar, I'm going to pour in some of my indicator. There you go, clearly vinegar. What to do next again? So we fill our glove with a bit of baking soda. There you go. So I'm just doing it to prove to you that I'm not cheating in any way. I am using baking soda. I am going to pour it into the glove. Maybe not as much as last time, because all we want to see this time is the color change and of course the reaction. Right, there we go. Going to pour it in, and you watch the color. Ooh. Once again, I overdid it. Good thing we have our tray to keep the kitchen table, the kitchen counter clean and try to make not that much of a mess. But what happened here now is, I think you could all see again, you know, the carbon dioxide, how it was coming up, rising up into the glove and making it stand up. And more importantly now, this time, because we know what happened, we also know that the vinegar turned into a neutral solution. And the reason for that is because we poured a base into the acid and it neutralized the acid. So compare the color, purple, purple, neutral. So we've learned loads today, haven't we? We know about baking soda and vinegar. We know that baking soda is a solid and it's a base. And we know about vinegar, which is a liquid, and it's an acid. And the two of them react to form a gas, and that gas is carbon dioxide. We also know about acids and bases in general, and we know how to distinguish between an acid and a base in a way that does not require us to taste or to smell or to touch any of the substances, because that's actually a huge no-go in chemistry. We don't ever touch or taste anything that we use in the lab. But what we can do instead is using something like an indicator. And it was, again, something we've learned today, was Waterford-born, or Lismore-born, and Robert Boyle, who was the first one who actually used the indicator in that scientific way. And it's a method that we still use in chemistry every single day. It is one of the key things that we're using in chemistry. Of course, we don't use red cabbage indicator, but the concept is still the same. You might have wondered when you see all those lovely colors, the red, the blue, the purple, if this could be maybe used as food coloring. Because in the end, it's all going to be about kitchen science day, kitchen chemistry, and what we do take away from that is that we can use things that we use every day in the kitchen to do science experiments at home. So, the food coloring question. It is a very good question, and it is absolutely possible to use red cabbage to color your food. I have something prepared which I will demonstrate you in a minute, and you can do that at your own pace at home and see and work, play around a little bit with food coloring and using red cabbage as food coloring. But if you do not like the smell of red cabbage, or if you don't want to color your cupcakes or cake or muffins or whatever using red cabbage, you can always go back and use blackcurrant, for example. I think blackcurrant works quite well. The colors are not as intense as they are now with the red cabbage, but they still look great, and it's a great alternative. The reason that different plants, even flowers like violets, for example, they would work as well. The reason why that works is that they all have a certain chemical inside, and that chemical, it's a water-soluble pigment. It's called anthocyanin, and it changes slightly in terms of what this pigment looks like, depending on whether you mix it with an acid or you mix it with a base. What we've also learned today is about baking soda. It was not just for fun that we were doing that experiment with the glove and the hand, being blown up by carbon dioxide. But what's behind that is actually that baking soda reacts in a similar way when you mix it in your dough, when you have bread or when you have cake. And because of the gas that develops, it makes your cake really fluffy, and it makes your bread quite fluffy as well. Okay, now let's go back and I show you how to get some color into your noodles. This is what I have. What we do with those noodles is I also prepared a huge pot of cabbage indicator. And I think you can guess what we're going to do is I'm going to put both of that into a pot. I'm going to quickly boil it up, and then I'm back with you in a minute. So I've boiled my noodles now for a while, for about 5 minutes in red cabbage water. And this is what I got. Purple noodles. Purple is great, but I think we can actually do more with that, because what we know is that we mix it with a base, turning blue. If we mix it with an acid, it's going to turn purple. From purple into red or pink. Let's give it a try. I have some vinegar here, and what I have in there is just some baking soda dissolved in water. Going to go for the baking soda first. I'm going to use a spoon to get a little bit out and spoon it onto the noodles in the corner down there, directed towards you. And what do you expect to happen? So baking soda onto noodles. At the moment it's purple. We are adding a base. I can see a change. I know you can't, because I'm doing that at the part that's directed towards you. And I think the plate is a bit in the way. But I'm going to show it to you now in a second. I think you can already see the change here. we have some kind of bluish noodles down there where I put the baking soda, and up here everything is still purple as it was before. So that's a way to kind of play with your food, but in a meaningful way. You know, we don't play with food, of course, but this is science and you can learn a lot from that. And well, next time just try, you know, eating some colorful, happy noodles instead of staying with the plain white ones. Now, if you want to try it at home, you don't need to use vinegar, of course. You can also use anything else. For example, lemon juice or lime juice works quite well. I'm going to use some vinegar on these noodles here now and see, can we see a change? So I'm just going to dribble it over those up there. And I think, I'm not sure if the light is good enough here now, but I can see a change, that these ones up there are a bit more pinkish now than they were before. I think you can see it as well, that there's a more pinkish color developing up there. Then it's darker, and then down here it's going into blue. Great, that's some inspirations for home. Give it a try. Get some noodles. Maybe try, you know, with cupcakes. Go for blackcurrant. You don't need to use red cabbage, as I was saying, but it would give the best color. See what else you can do in the kitchen. This workshop, I think, gave you some inspiration and also explained a few things that are happening in the kitchen, and also things like an indicator that are quite important concepts in chemistry. I hope you enjoyed it. I did. I think I'm ready now for dinner. And yeah, see you soon. Thanks.